All right, so welcome to section 10.3. We are going to continue talking about the circle. So we're going to start out with lots of definitions. So again, I'm going to go pretty quickly, but you guys can always pause this video, and I recommend you guys copying down all of the definitions, but I'm not there, so hopefully you just listen to this old woman. Okay, so first, an arc. So essentially an arc is just a piece of the crust. Okay, so that's what an arc is. It is literally a piece of a crust. Now there's different kinds of arcs. So the first one we're going to talk about is something called a minor arc. And a minor arc is an arc that is smaller than 180 degrees. So previously, I know that you guys have seen AB as a segment. I know you've seen AB as a line. When we're talking about an arc, we put an actual arc above it, kind of like a half circle looking thing. And that means that we're actually referring to this piece from A to B. Okay, so again, a minor arc, and you guys are just gonna see a minor arc labeled with 2 letters, and that's talking about the crust from A to B. Very different than if you guys were to see, AB with a segment over it, that would be talking about the segment that connects AB, or the chord. Again, we're talking about arc AB, and that's considered a minor arc. Then we have a major arc. So a major arc is an arc that's obviously more than 180 degrees. You guys are going to see it labeled with 3 letters, because if I just said AB, that's what we just did. So when they say AEB, again, from A going towards E and continued to B. So this would be considered, again, major arc, AEB. Now again, this is very different than angle, AEB. I can connect A to E to B as an angle, but I'm not referring to that. I'm talking about the crust from A to E to B. So again, minor arc, 2 letters, major arc, 3 letters. And then we have a semicircle. So a semicircle is exactly equal to 180 degrees. And once again, if I was talking about semicircle AD, it wouldn't matter which way you go, because AD going this way and AD going this way are both 180 degrees. If you wanted me to go in a specific direction, you can tell me to go, for example, from A to B to D, and that tells me you're specifically looking at that part of the semicircle, okay? Are arcs that have the same measure congruent to each other? So this idea of congruent means that if you were to actually cut something off and place it on top of the other one, that they would actually fit. Now I want you to think about this. Arcs that have the same measure. If I was to draw 2 different circles, so let's say that's circle 1. I'm gonna give them letters like I should, right? We'll do circle A and we'll do circle B. And what I'm going to do is I'm going to draw a semicircle. So I'm going to draw this arc right here. And this arc is 180 degrees. I went halfway around the circle. I'm also going to do the same thing over in circle A. So this is also a 180 degree arc. Would I say that these 2 arcs are congruent to each other? Does it look like I could actually cut this orange one off and fit it on top of the pink one? No. Just because they have the same measure does not mean they are congruent to each other. A piece of crust on a small pizza is not equal to a piece of crust on a large pizza, okay? Just because they have the same measure does not mean they are congruent, okay? In order for 2 arcs to be congruent, there has to be some stipulation. So 2 arcs are only considered to be congruent if they come from the same circle, or if they come from congruent circles. Okay, so once again, circles are congruent if their radius is congruent to each other. So for example, if this radius is 5 and this radius is 5. So if you guys knew that the radii were congruent to each other, then we can say that the arcs are congruent to each other. Then arc EF has to be congruent to arc GH. This arc has to be congruent to this arc. Again, only if they come from the same circle or from congruent circles. Again, taking a look at this one, I can start fresh here. Because this is coming from the same circle, again, these have the same measure, but I know they are congruent because they're coming from the same piece of pizza, essentially. They're coming from the same circle. So I can say that arc AB is congruent to arc CD because they're from the same circle, okay? These have the same measure, but they are not congruent. These have the same measure, and they are congruent. These have the same measure, and again, they are congruent because they came from congruent circles. Okay, so those 3 examples. A central angle, so we're going to be now talking about angles inside circles as well. So a central angle is an angle in the circle whose vertex is at the center, okay? And the measure of that angle is going to be equal to the measure of that arc. So again, here's a circle, and we'll call this center C, that's the center. If I was referring to a central angle, ACB, angle ACB is a central angle, okay? We call that a central angle because the center is the vertex of the angle. Now, if I was to tell you that this angle is 70 degrees, the crust is also 70 degrees. So if angle ACB is 70 degrees, then arc AB is also 70 degrees. Okay, and that way, again, if you guys were to divide up this triangle, like let's say this was 100 degrees, again, this crust right here would have to be 100 degrees. Let's do another one. If this one right here was 60 degrees, then this crust right here would have to be 60 degrees, so on and so forth, all the way around your circle. And this is only true for central angles. So we're only working with central angles, okay? And more information here. Okay, so this was a lot, so I put these theorems kind of all together here, and I used colors. So if 2 central angles are equal, so if those blue angles are equal, then those pink arcs have to be equal. Obviously, if the blue angles are 50, the pink arcs have to be 50, okay? The converse is also true. If the crust is equal, then the central angles have to be equal. My next 2, 81 and 82, now we're looking at the blue and the yellow. If the central angles are equal, then the chords, the yellow chords, if I were to connect those points from A to B and from D to E, those have to be equal to each other. And the converse, if the yellow chords are equal, then the central angle is equal. And then the last 2 that we're talking about are referring to the pink and the yellow. Again, if the arcs are equal to each other, then the chords are equal, and if the chords are equal, then the arcs are equal. In other words, if you're working with the same circle and you have a congruent, let's say congruent arcs, then the chords joining those arcs are congruent, and the angles, central angles making those arcs, are also congruent to each other. Okay, and this is just, again, the same thing. If the chords are equal, the arcs are equal, then the central angles are equal. If the central angles are equal, then the arcs are equal, and the chords are equal, and yada yada. Okay, so let's put this into play. We have circle B here, and it says D is the midpoint of AC. Now notice the notation. This is saying arc AC. So in arc AC, D is in the middle of that. Okay, so we're going to go ahead and write this out. So step 1, we have circle B, and D is the midpoint of arc AC. That's given information. They told us that. What can I pull from that? Well, I can pull that arc AD is congruent to arc DC. And why do I know that this arc is equal to this arc? Well, because D is a midpoint. So if a point is a midpoint, then it cuts the arc into two congruent arcs. So it took that arc and it cut it into two congruent arcs. Now here is what we have been talking about. So if I have arcs that are congruent, then the angles that make those arcs also have to be congruent. So next I'm going to say angle ABD has to be equal to angle DBC. And again, that's if arcs are congruent, if the pink arcs are congruent, then the central angles are also congruent. So again, if those pink arcs are congruent, then the central angles also have to be congruent to each other. And that leads me to what I'm trying to prove. So I'm trying to prove that BD is bisecting angle ABC, and that's if a ray cuts an angle into two congruent angles, which it did, you can see that right here, I have two congruent angles, then it was bisected. Again, the then part has to be then it was bisected, because that's what I'm trying to prove. I'm trying to prove it got bisected, and I just did. Okay. For this one, it asked me to find the measure of angle A. So what that's referring to is this actual angle measure right in here. And so a couple things. First of all, they're telling me that the crust from A to B is 102 degrees. If the crust from A to B is 102, then the central angle is also 102 degrees. Okay, so I pulled that out. The next piece of information, now I'm working with circles, so I know that the radii are congruent to each other, which makes this an isosceles triangle, which makes this x also equal to this x. So to do my math, if I did 180 minus 102 to give me 78, if I divided that into two equal angles, each of the angles has to be 39 degrees. So the measure of angle A has to be 39 degrees. Okay. Here we go. What fractional part of a circle is an arc that's 36 degrees? Okay, so once again, we have a full circle. And if I was to take an arc that is 36 degrees, what fraction of the circle is that? So I would say it's 36 out of the 360 degrees, which reduces to 1/10 of the circle. Okay, what fractional part of a circle is an arc that's 200 degrees? Again, 200 over 360. I immediately knock off the zeros, and then you can reduce this. And if you guys struggle with reducing, just divide it by 2. 10 over 18. Oh, I can divide by 2 again. 5/9. So what fractional part? It is 5/9 of the circle. Okay. Part B, it says find the measure of an arc that is 7/12 of its circle. So a couple ways you can go about this. One, you can actually do 7/12 of the 360 degrees. Okay, and you can actually multiply this together. I would probably do it this way. 12 goes into 36 30 times, and so this would be 210 degrees as my final answer. A second way of setting this up is 7 out of 12 has to equal how many degrees out of 360, and then you guys can go ahead and cross multiply, or you can just use mental math. To get from 12 to 360, you multiplied by 30, so 7 times 30 is going to give you an equivalent fraction, which again makes this 210 degrees. However you guys would like to set this up, there's lots of different ways. Some people probably are going to do 7 divided by 12 to actually come up with a decimal, and then multiply that by 360, and that's fair game as well. Okay, so again, we're working with arcs, angles, chords, lots of vocabulary here.